Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet with me, Richard here. Yes, tonight we are looking at this question. It says that 50 cubic centimeter of 0.2 moles per cubic decimeter of solution of oxalic acid neutralizes 30 cubic of sodium hydroxide solution. And the first question says, what is a standard solution? What is it? Okay, a standard solution is a solution of known concentration. Yeah. Then comes this question. It says that identify which of the two reacting solutions above is a standard solution. So we are having two solutions reacting. One is oxalic acid and the other is sodium hydroxide. And the question is, which one is standard? Okay, from the definition of standard, a standard solution must be a solution of known concentration. Okay? So which one of the two is of known concentration? The answer is oxalic acid. It is the one whose concentration here is known. As for sodium hydroxide, we have the volume, but we don't know the concentration. Yeah. Then comes this question. It says that calculate the concentration of sodium hydroxide. How do we go about that? Okay, this is how we analyze the question. You look at our standard. This is what we know about the standard, which is oxalic acid. And what do we do about the standard? We calculate number of moles of the standard solution which is reacting. So what do we write here? You say calculating the number of moles of oxalic acid reacting. Yeah, that's what we do first. Okay, because we know it's the standard, you have to realize here that we normally move, or we always move actually from known to unknown. So it's the oxalic acid which is known here. So how do you calculate number of moles? You list what you have. Okay, you have the concentration, which is 0.2 moles per cubic decimeter. What else do we know? We know the volume, which is 50 cubic centimeters. So what do? We change it to cubic decimeter because this is per cubic decimeter. So we say 50 divided by 1000, giving you 0.05 cubic decimeter. Okay, what are we looking for? We are looking for any number of moles which reacted or which are reacting with oxalic acid. So from this, you quote the formula. The formula says C is equal to N over V. So C is known, it's going to be 0.2. N is wanted, but the volume is known and is 0.05. So from here, we know our N, and what is it? It's going to be 0.2 times 0.05. So there we are. So what we have here are the number of moles of oxalic acid which are reacting. So after getting them, what do you do with them? You have the equation. The equation is oxalic acid, which is this one. I would urge you that to make proper sense of this, I normally use the structure of oxalic acid. So this is the structure, and we're adding sodium hydroxide. Okay. And what do we get here from the equation? We are going to get this, which we call sodium oxalate plus water. Those are the two products we have. Next is to balance. Okay, when you look at sodium, here is 1 and you have 2 sodium there. So what do? We put a 2 here. When you put a 2 here, then hydrogen is 4, so you put a 2 here. Now hydrogen is balanced. So what we get from the equation is the mole ratio. We have 1 here, because the number which is here is 1, and we have 2. So the purpose of the equation was to give us the mole ratio. But here you have to know something. From the mole ratio, it's a guiding us. We know this 0.01 moles of oxalic acid. So for oxalic acid, we know it. It is 0.01. You have to know that here we strictly use moles. We don't use mass. We don't use concentration. What works with the mole ratio is number of moles. And an assumption that our number of moles of sodium hydroxide is X, what do we do here? What we do is to cross multiply. Okay? From here, what do we say? We are going to say X is equal to 0.01 times 2, giving you, yes. So we know this. So what are these ones? These are the number of moles of sodium hydroxide which reacted. So under the circumstance, what do we do? You list everything you know about sodium hydroxide. So let us have it here. This is sodium hydroxide. So what do we know about sodium hydroxide? We know number of moles which reacted. We know N, which is going to be 0.02 moles. Okay. What else do you know about sodium hydroxide? We know the volume. The volume is 30 cubic centimeter. So what do? We change it to cubic decimeter by dividing. What we are going to get here is going to be 0.03 cubic decimeter. So after this, then what do? We go for the concentration. The equation says C is equal to N over V. Okay? And we know N. What is it? 0.02. And we know V. What is it? 0.03. What you get out of this is going to be the concentration of sodium hydroxide. Yes. So we have it here. This is the concentration of sodium hydroxide. It is 0.67 moles per cubic decimeter. Okay. Then comes this question. It says, calculate the pH of sodium hydroxide. Okay, how do you go about this? This is what you have to know, that pH is equal to negative log hydronium ion concentration, or negative log hydrogen ion concentration. So it is sodium hydroxide we are considering. So this is what we know about sodium hydroxide. Okay. We know that it is sodium hydroxide. On dissociating, what do we got? we have sodium ions plus hydroxide ions. Okay, with this, what do we do? This is what you have to remember, that we just calculated the concentration of sodium hydroxide, which was 0.67 moles per cubic decimeter. Remember, on ionization, 1 mole of sodium hydroxide release 1 mole of sodium ions. So this one is also going to be 0.67 moles per cubic decimeter. Also, this one is going to be 0.67 moles per cubic decimeter. Now you have to know that we are faced with a challenge here. The concentration we are considering here is hydronium ions, and we don't have it anywhere here. So what is the escape route? The escape route is that we know that for a solution, the concentration of hydronium ion multiplied by the concentration of hydroxide ion is giving you 1 times 10 power minus 14. Okay? So this is what we call Kw, water dissociation constant. What happens that this one is constant, so whatever happens here, this one's add just to maintain it constant. Okay, so what do? We have the concentration of hydroxide ions, which we can put here. So what are you going to say? We are going to say concentration of hydronium ion, because it's what we are looking for, is what we are supposed to use, times what? 0.67 is equal to 1 times 10 power minus 14. From here, what are you going to say? We are going to come here and say concentration of hydronium ion is equal to 1 times 10 power minus 14 divided by 0.67. So there we are. Now we have the concentration of hydronium ions, which we need to put in our equation. So what is the next step? Next step is going to be substituting in the equation. It's going to be pH is equal to negative log that, which is 1.493 times 10 power minus 14. This one gives you, it gives you 13.83 as our pH of sodium hydroxide. So comes this question. It says that calculate the pH of oxalic acid. Okay. So how do we go about this? We know that pH is equal to negative log hydronium ion concentration or hydrogen ion concentration. Now here, our assumption is going to be an assumption, because when you go to higher levels, like at university, you realize that oxalic acid is not a strong acid, so it doesn't undergo complete ionization to release all the ions. So there is a trick there, but it's not addressed at this point. At this point, our assumption is that oxalic acid is completely ionized, which is defeating the meaning, but let's proceed. So if it's completely ionized, so what are we going to say? Now, we have to look for the concentration of hydronium ions, which are coming from oxalic acid. So this is what you have to know about oxalic acid. It is this. I prefer to use the structure when it comes to oxalic acid. Okay. This is the oxalic acid. This is the structure. In exam, they're going to write it as COOH with a 2 here, but I'm going to use this one. So what happens is that if this one breaks down, I'm avoiding to put water because it will complicate it. So if this one breaks down, this is what you're going to get. You're going to get 2 hydrogen ions, then plus that. Yes, this is what you get after ionization. Okay. Yeah, these 2 are the 2 ionizable ions, and we have them there. So in other words, what does this mean? I want us to assume that what you have here are hydronium ion. Yes, actually hydronium ions are hydrogen ions in solution. And remember, all the acids are in solution, so we can as well quote hydrogen ions as hydronium ions. So what do we do? This is what we are seeing, that when 1 mole of oxalic acid ionizes, it produces 2 moles of hydronium ion. And we know the concentration of oxalic acid. What is it? It is 0.2. So we are looking for these, because this is the true value which is supposed to be substituted here. So what do we do here? We are going to say X is equal to 2 times 0.2, giving us 0.4 watt moles per cubic decimeter. These are the number of moles of hydronium ions present on assumption that oxalic acid completely ionizes. So after getting these moles, what do? We substitute them here. We are going to have pH is equal to negative log 0.4, giving us, so our pH is this. It is 0.4 for oxalic acid. Okay. Yeah, then comes this question. It says, state the pH of the resultant solution at equivalent point. Write greater than 7, less than 7, or equal to 7. Explain your answer using equations. So how do we deal with this? Okay, this is what you have to know, that we're having a reaction which is between oxalic acid and sodium hydroxide. Okay? This reaction will give you that salt, which is sodium oxalate plus water. Okay? Now, the question is, this salt formed, how does it hydrolyze? So the question is behind hydrolyzation. So this is how we deal with the salt. You analyze the salt. Okay? What do? You break it up into its constituent ions. Okay? You break it up here, and you have oxalate ion, and you have the sodium ion. And we know that this one comes from a weak acid, and this one comes from a strong base. Yes, this one comes from oxalic acid, which is weak, and this one comes from sodium hydroxide, which is strong. So in that case, we have to know that ions from strong base or acid does not undergo hydrolysis. So that leaves us with only one ion, which is what? Oxalate ion. So it's the one which is going to react with water. So when it reacts with water, this is what we have. Okay. It will take up a proton. It's negative, so it's going to be COOH. COOH. When this water loses a proton, what remains behind is OH minus. From there, what do? You go ahead and balance. Okay, these are 3. So if you put 2 here to make it even, then we have 4H. And how to make this 4H? You put a 2 here. Okay, now it is balanced. But the issue is about pH. How do you assess pH after hydrolysis? You look at the product. Once you have OH as part of the product, what does that mean? Medium is basic. So pH is what? Is greater than 7. Okay. So that is that. So the answer here is this. Or we can write it here and say greater than 7. Okay. And with that, I would like to say thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Yes, we thank you for your time. Don't forget to subscribe, to comment, to like. We recommend that if you're using the channel, please use playlist, not the video. Just go to playlist and choose the material which belongs to your level. Grade 8 and 9, look for Natural Sciences Grade 8 or Natural Sciences Grade 9. For grade 11 and 10, look for Physical Sciences Grade 11 or Physical Sciences Grade 10. As for grade 12, each chapter is presented independently, so just look for the chapter of your interest. And there you are. You have all the material which you need. With that, I would like to say thank you. See you next time. Bye-bye.